So we're Math4kids Pro X 3000, and we're going to present our app. So,
Can you make it full screen?
I think, yeah, I will make it full screen. So the contents of this presentation are the introduction, project justification, the app design, the user testing, and discussion reflection. And the introduction will be done by Maria.
Okay, so yes, I'm Maria, as Aspet mentioned before, and I will show you, explain you the introduction of our presentation. Mrs. Teacher Belinda explained to us that the learning needed and contextualized the use in Sarawak, Malaysia. Teacher Belinda teaches children between 7 and 9 years old, so primary school in a rural school, in a rural area in Kampung Kwan. The internet connectivity and the technology is limited, so education suffers because of this problem. Is worse now due to COVID-19. Platforms to help children and learn and provide educational learning exist. These platforms require connectivity, and the solutions needs to be offline so that the children with no or limited internet access can still use it. A solution that makes use of gamification is preferred since the kids have fun while learning. Next. Now I will present the project justification. Can you slide? ICT4D has become an increasingly popular research topic over the years. Currently, there are existing apps that have been developed with the aim of providing students with education or existing students in improving their educational skills. It's also important to keep in mind several factors when developing apps that are tailored to the needs of the students in the global south. One important factor is access to internet and connectivity. This means that the app should be developed should take into account the fact that there are areas in the global south where people have limited access to internet and where connectivity issues might occur. A possible approach to deal with this problem is to create an app that only requires the user to have access to the internet when downloading and allows the user to use the app with or without internet. This approach has the advantage that the user is able to use the app whenever or wherever they want. We should keep in mind that the app should be sustainable, and moreover, the system should be able to maintain itself of the user, or the user should be able to maintain the system easily. Next.
Okay, so the stakeholders and goals. The first stakeholder is like the students who have as goal to improve their mathematics skills and while having fun. The second stakeholder is the teacher who motivates the children and improves their teaching method with the assistance of the app. The third stakeholders are the parents who have as aim to support their children and motivating them. And the fourth is like the government with possible financial contributions. The fifth stakeholder are the app developers who develop a technological solution, and that can be further developed by UNIMAS. So another important aspect to keep in mind is the ethics. So this educational app has its purpose to help the students and help them reach the goal of equality education. And if the app is using their data, then we must protect it so that it cannot be taken advantage of. And we can avoid this by introducing rules and regulations. So next, we're going to talk about the app design. First off, it's important to consider like the needs and limitations of the users. So the app should be tailored to the needs of the primary school children. The kids struggle with basic math operations, such as addition, subtraction, multiplication, and division. They have trouble with counting numbers and recognizing them if they're above 20. And they struggle also with mathematical sequences. So these are like the needs, like the points that they want to improve. And then also it's important to consider the accessibility when designing the app. So we did this by having grouped exercises in the app, an organized and clear interface, easy to use, and the app is easy to use and get acquainted to. Malay as main language. The background and text must be easily distinguishable, and a color scheme must be used that is like more usable for visually people with visual disabilities. Okay, so next we also took the limitations into consideration. And we already know that the children have limited or no access to the internet, and they might experience connectivity problems. So therefore, the solution is downloadable and usable offline. And the last important point is to make the app sustainable, as we mentioned earlier. Okay, so now Maria will provide the prototype description.
In this slide, as you can see, the main screens of the app. In the first picture depicts the loading screen. The second picture depicts the initial test. The third picture depicts the main display when the user will see 5 different math signs and vocab and logic problems, and then answers questions and adjustments. Next, before. Yeah, this one. And as you can see, there is a main menu where you can choose what you want to practice and an option to go to the vocabulary list and settings. And the user first takes to assess, yes, in the initial test, first takes to assess their skills. Based on this test, they will be advised to make a specific exercises through the different math signs. But the user can do the exercises as she or he or whatever likes. Can you swipe? In this slide, you can see that for each concept, there is an explanation, 3 different levels, and 5 exercises per level. In the examples, there is, for example, we take into consideration number sequence as one of the math signs, and then the user will move his or her finger through the levels to click one of it, and then the app will provide 5 different exercises. And then for each level, we'll have 5 exercises. As you can see in this example, there are only 3 exercises of the number sequence, but in the app design, there are more examples of number sequence and more examples for each of the levels of this math sign.
Maria, you have 1 minute still.
So you can swipe. Well, no, before. Okay, so talk and let's go.
So considering like this, the software, we were thinking of an intelligence tutoring system and the cognitive tutor authoring tool CTAT software can be used as the base of our application. And some added AI technologies can be used for like speech and visual recognition. We want an adaptive approach. So the ITS adapts to the user based on the input. And there will be like, there has to be like real-time feedback. And it's also important to have reports of the performance of the students. We'll quickly go through this slide. So through an adaptive approach, the students will learn through the app, and using the ITS, they can support the educator in both knowing which math sign a student struggles with. The ultimate goal is to improve the students' abilities in mathematics, and by using a real-time report of the development of students, that also we can also track their performance over time. So for user testing, we were thinking of an agile approach, which means that we have cycles, including the app design, the creation of the app, and then we get user feedback, and based on the user feedback, we'll adjust our design. And in this design, the stakeholders are heavily involved. So because we take, for example, the feedback of the students, and we have like a close collaboration with the teachers as well. So some points for discussion and reflection are like time constraints, the design choices such as AI elements, why we did and did not make certain design choices. It's because sometimes of time constraints, and sometimes just to make the app like, it doesn't have to be a super cool app, but it should just be tailored to the students' needs. The languages, because we made our prototypes in the English language. However, it would be favorable to have them in Malay, since that's the main language. And due to COVID-19, we weren't unfortunately able to like actually collaborate with the students, which would have been nice. So this was our presentation.
Thank you. Thank you, Jesper. Thank you, Maria. Thank you, Group 2, for the nice presentation. And to the audience, I ask if there are any questions to group number 2. I'm sure that there will be a question. Francis, don't you have a question to group number 2?
Can I give comments?
Yes, that's yours, Katina, of course.
I'm really amazed with the efforts that Group 2 have put, because none of them from Malaysia, but in the group, none of the students are from Malaysia, but they managed to get it done with the teachers. And one of the teachers, so I would like to ask, what is your, experience that you gain, or any difficulties that you are facing when you try to communicate to the community with someone from Malaysia, maybe to translate for you?
Well, one of the main limitations that we have, for example, it's time lapse, because between Europe and Malaysia, there is like a difference of hours of six hours between. So this means that, for example, when we send the first, yes, and the only user test that we have done, we spend like from 11 p.m. till 2 p.m. chatting through the WhatsApp group. And teacher Belinda and Che provide us a lot of suggestions and improvements, but the design, of course, I don't think that we will have time to develop all the design that requires this app, but for this reason, we try to summarize the design in a few minutes, but we couldn't, as you can see. And yes, and there's a lot of work behind this. And yes, if you want to know more about the app and how this app can be developed, well, Che said us that Uni Malaysia can develop it, and one of the students could develop. So we are looking forward that this app will be developed, and of course the students will be satisfied with the learning approach of this app.
Thank you.
Okay, thank you, Maria, for the explanation. Yeah, it's very eye-opening to us when we want to try to do it online from Europe with the time difference. But still, I'm amazed, and it is a really good effort to start with. Yeah, congratulations.
There's a question from Gideon. Gideon, want to ask yourself, or shall I read it? Okay, then I will read it. What teaching and learning materials are you employing in your design to make the pupils enjoy learning maths? That's the question by Gideon. Can you answer that?
I can answer that one. We were thinking of using game mechanisms since teacher Belinda told us that the preferred way of teaching for the kids would be through games. So we thought we would use that to keep the kids occupied and to make it fun.
Yeah, it's like a gamification approach.
Yeah.
We mathematics is like actually quite abstract, but then in our app design, for example, here you can see like here it's like about fruit. So then they are like involved with counting fruits. And this is how how it's like made easier for them and how it's kind of made more fun. Since it's just not like numbers like 1, 2, 3, but it's about fruit and other stuff like pencils. And then when they actually get the hang of it, then it will get a bit more abstract because they will realize it's not about counting fruits, but it's actually about numbers.
Okay, thank you. Thank you very much.